All right, let's jump right in. We are absolutely swimming in data these days, right? But here's the thing. Just having a mountain of data is totally different from actually getting answers out of it. And that gap gets huge when your data gets, well, big. So today, we're going to look at the tool Google built to fix that exact problem. It's called BigQuery.
You know the feeling, right? We've all been there. You're just trying to do your job in a tool you know and love, like Google Sheets or Excel. Maybe you're looking at sales numbers, or maybe it's website traffic. And for a while, everything's great. It's smooth. But then, your data set starts to grow, and then it grows some more. So what happens then?
Yep, exactly. You get that dreaded loading bar, the spinning wheel of doom. There was this great example where an analyst showed that even a sheet with just 50,000 sales records, which sounds like a lot, but in the grand scheme of things isn't huge, can make the whole thing just stop working. Simple math takes forever. Filters freeze up the app, and suddenly you're spending more time waiting than you are actually analyzing anything. The very tool that's supposed to help you has become the biggest bottleneck in your day. So here's the bottom line. Spreadsheets just hit a wall. They have a limit. BigQuery, though, it's built for a whole different universe of data. We're not talking about thousands of rows anymore. We're talking about trillions. It's designed for what we call petabyte scale data, and it can chew through complex questions in seconds, not minutes, and definitely not hours. It's like comparing a go-kart to a rocket ship. It's a completely different league. And that brings us to what BigQuery is. It's super important to understand this. It's not just a giant spreadsheet. No, it's a fundamentally different way of thinking about storing and analyzing data. The term for it is a cloud data warehouse. Okay, so that's the fancy official definition. But let's unpack that a little. A data warehouse. Just think of it like a massive central library for all your information. But the words that are the real game changers here are serverless and fully managed. So what on earth do those buzzwords actually mean for you? Serverless basically means you can forget about the hardware. Seriously, you don't have to pick out servers, you don't have to install updates, and you definitely don't have to panic about what to do if you suddenly get a massive flood of new data. Google takes care of all that stuff in the background. It lets you focus on the fun part, asking questions of your data instead of turning into an IT infrastructure expert. Oh, and if you already know SQL, you're pretty much good to go from day one. So, the big question is, how is any of this even possible? How can BigQuery sift through billions of rows so incredibly fast? Well, the answer is in its DNA, its core architecture. It's the secret sauce that makes it all work. And it really boils down to two brilliant ideas. Okay, first, let's talk about the old way of doing things. Traditional databases use something called row-based storage. Just picture that spreadsheet again. All the info for a single sale, the order ID, the date, the customer name, the profit, it's all stored together in one long line, one row. Now what if you only care about one thing, like the total profit? Well, too bad. The database has to read the entire row, all that other stuff you don't need, just to get to that one piece of information, for every single row. You can see how that's just wildly inefficient. BigQuery just flips that whole concept on its head. It uses what's called columnar or column-based storage. So instead of storing by row, it stores by column. All the values for total profit live together. All the values for region live together. You get the idea. So now when you ask for just those two columns, BigQuery only has to read those two columns. It gets to completely ignore everything else. This one change dramatically, reduces the amount of work it has to do. All right, part two of the secret sauce is this. The place where the data is stored and the engine that does the thinking are completely separate. They're decoupled. Your data lives in Google's file system, Colossus. The best way to think of it is like an infinite library that can hold anything. The actual analysis, the number crunching, is done by an engine called Dremel. And Dremel is like having thousands of genius researchers who can all work at the same time. And the link between them? That's Jupyter, a crazy fast network that's basically a data superhighway connecting the library to the researchers. Okay, so this architecture isn't just some cool computer science theory. It has a real massive impact on how you actually work with data. So let's see how this all plays out in the real world, especially when we talk about two things everyone cares about: speed and money. This right here, this is probably the single most important thing to get about using BigQuery. Because it stores data in columns, the cost and speed of your query depends on how many columns you ask for, not how many rows are in your table. Let me say that again. It's about the columns, which means being specific makes your queries faster and cheaper. And this example just nails the point home. This is from a real public dataset with millions of rows.
If you're lazy and you just type select star, which means give me every single column, you end up scanning about 3 gigabytes of data. But if you take a second to rewrite that query to only ask for the 2 columns you actually need, say name and rank, you only scan 876 megabytes. That's a reduction of almost 75%. You did 75% less work and paid less for it just by being specific.
Okay, so we get the how. We understand the power and the core ideas. But so what? What are people actually doing with this thing? How does all this cool tech translate into actual real-world value? Well, for starters, it's actually really accessible. The pricing model is basically pay as you go. You pay a tiny bit for the data you store, and then you pay for the data your queries scan. And hey, you now know the secret to controlling that. But here's the kicker. Loading your data in and getting it out, that's free. That right there removes a massive barrier for anyone just wanting to try it out. And because it's so accessible, it's being used everywhere, in tons of different industries. You've got marketers using it to track customer journeys in real time, not last quarter. Financial companies are sifting through huge transaction data sets to spot fraud as it happens. And you even have healthcare researchers analyzing complex genomic data, trying to speed up scientific discovery. The applications are massive. And it's not like BigQuery is just off on its own little island. No, it's plugged into a whole ecosystem. You can hook it up directly to visualization tools like Google Data Studio and build these amazing interactive dashboards. And this is super cool. You can use something called BigQuery ML to build machine learning models without learning a new language. You can do it right there with the same SQL you're already using. So, when you zoom out, what's the big picture? What's the one thing you should really take away from all this? It really all comes down to a shift in focus. And this quote just says it perfectly. For so long, doing this kind of massive data analysis was something only huge companies could afford. You needed big budgets and armies of engineers just to keep the lights on. But tools like BigQuery are changing the game. They take care of the infrastructure headaches for you, which means that pretty much anyone with a good question can focus on what actually matters, turning all that raw data into something genuinely useful.
And that really leaves us with one final thought. Once you remove all the technical roadblocks, all the performance limits, what's left? Just your own curiosity. So leave you with this question. If you had a tool that can analyze pretty much any data set you could dream of, no matter how ridiculously big, and get you an answer in seconds, what's the first thing you'd ask?